Alright, these are the accumulator function notes. I would use this, I don't know, near the end of the section 4.4. Definitely before the super sheet. Alright? Alright, so you don't, okay. So, generally an accumulator function is given with a graph, but it doesn't have to be. Okay? And an accumulator function looks like this. So, the way I'm discussing this, as if I was talking about a new breed of functions, right? Like a piecewise function is made up of functions, but it's kind of different from regular functions. So an accumulator function is a function that's made up of an integral, right? So here, this is the integral. So g, I'm defining g as an integral function of f, and this is the graph of f. So the function of f is given by this graph. All right. And g is defined as the integral. All right. Let's just go dive into it. All right. So what we can do, remember, keep in mind that this is an area, right? This is going to find the area of this graph. So if I look at for g of 4 will be what is it from 4 to 4 of f of t. Well, keep in mind, whenever you have an integral and the limits are the same, it's just 0. So it acts normal. Okay, there's nothing special about this accumulator functions. Okay, and here, so g of 8 will be from 4 to 8 of f of t dt. Now this one I actually have to do something. So I'm looking at from t equals 4 to t equals 8. So just the area in here. And that's 4 by 4, so that's 16. So that's all that is. Okay, so you're going to find the area that represents from 4 to 8 of the function f on this graph, and that's it. So what about g of 14? G of 14 will be from 4 to 14 of f of t dt. And what is that? So 4 to 14. So you're starting from here and you're going all the way down to here. So that means we need, well, let's go ahead and check this out. Alright, so here, this part right here is negative, so it's going to cancel with this negative over here. So let's just go up to 10. So we'll go from 4 to 10. What happens from 4 to 10? So this part is 16. So all I got to do is figure out this little piece right here. And I'm just going to count it. 1, 2, 3, 4, 5. And those halves together make 6. So it's 6 plus 16 or 22. Okay, so you have the paper, and if I made a mistake, you know, look it up. All right, let's look at what it is from 4 to, so g of 0, look, it's from 4 to 0. Right? Keep in mind, you're not going to put them in order. You're going to put where the x is. So that means I'm going to go backwards. I'm going to go backwards, all right, of f of t dt. So since I'm going backwards, this is going to be a negative, or the opposite of what it is. So this is a positive area. So since I'm going backwards, it's going to be the opposite of that, so negative. And this area here, that's 4 by 4. 4 times 4 is 16 divided by 2 because it's a triangle. So that's negative 8. Okay, so that covers the basics of an accumulator function. So what I'm about to do next is look at examples where they treat it like a regular function. All right. So this is an example of a multiple choice question on an AP test. All right. The graph of the function f is shown above, consists of 2 line segments and a semicircle. So there's my 2 line segments and there's my semicircle. That semicircle has a radius of 2. Right? You just look at it. 5 minus 3 is 2. All right. Let g be defined as that accumulator function. What is the value of g of 5? So it's starting at 0 and going to 5, so we can ignore this side. 0 to 5. So that's going to be this piece right here, which has a height of 3 and a base of 1. So 3 times 1 divided by 2. So that area is 3 halves. This is a semicircle of radius 2. So that's going to be pi 2 squared over 2. So that's just 2 pi. So between the two of them, 3 halves and 2 pi, it's going to be 1.5 plus 2 pi, but it's not negative, so to find the positive version, it's d. So that's all that is. Okay? That's all that is. Page 2. So this is a full-blown free response question on like 2013 AP calculus test. Okay? So this is a accumulator function, and what we're going to do is explore all the possible ways they can ask it. Well, not all the possible ways, but most of the possible ways. So the graph of the continuous function is given above. All right, consists of 3 line segments in a semicircle, right? See the semicircle? So again, it's a radius of 2. So that's going to be what? 2. So the area is going to be 2 pi, right? 4 pi divided by 2 is 2 pi, all right? And let's just go ahead and do this. So this is starting at -2. So g of -6 is going to equal from -2 to -6 of f. So you're going backwards. You're going from here to here. So even though the area is positive, because we're going backwards, it's going to be negative. All right. And that's just the area of that triangle. The triangle has a height of 5. So remember, area of a triangle is 1/2 base times height. The height is 5, and the base is, what's that? 4. So the answer is 10, -10. And then g of 3, we're going to go from -2 to 3. So we're going to go up to 2, that's the semicircle, and then go down to here. Alright, so the semicircle, oops, let me write it out. So that's the semicircle has an area of 2 pi plus, and then the area down there, that's what? That's a height of -2 and a base of 1. So -2 times 1 divided by 2. That's going to give me -1. So you can just write minus 1. Right, so g of 3 is 2 pi minus 1. This was like question 5, so this is a non-calculated question. So they're not going to expect a decimal approximation. You could just give 2 pi minus 1. That's it. That's g of -6 and g of 3. All right. G prime of 0. So now we're going to use the second fundamental theorem of calculus, where we take the derivative of this accumulator function. Right. So the second fundamental theorem of calculus is associated with accumulator functions. So now here we're going to go ahead and take the derivative of that. So g prime of x is equal to f of x. Okay, so g prime of 0 means look up whatever f of 0 is. F of 0 is 2, so the answer is 2. And that's it. That's all it's looking for. Okay, so f of 0, plug in 0 into f, it's 2. That's it. It's not looking for the slope of f. Right, remember f is the slope of g. Alright. C. Find all values of x on the open interval -6 to 3 for which the graph of g has a horizontal tangent. Where does g have a horizontal tangent? In other words, when is f equal to 0? When is f equal to 0? And it's an open interval from -6 to 3, so you're not including -6 or 3. So when is it 0? Well, it's at 0, -2, and 2. Alright. Okay, so to answer the first part, find all values of x on an open interval for which the value of graph of g has a horizontal tangent. So g of x has horizontal. And by the way, on the AP test, they actually gave more space than this. I was just stingy on the paper. G of x has horizontal tangent at x equals -2 and 2. Alright. Alright, because the y values of f are 0. Alright, continuing. Determine whether g has a local maximum, minimum, or neither of these values. Just to fire over here. Alright. X equals -2 is neither max or min, because sign does not change. Sign of g prime does not change. And I really ran out of space, didn't I? Alright, so maybe I'll make more space on your sheet. Alright. And at x equals 2, it's going from positive to negative, so that is a max. There is a max because g prime changes from positive to negative. Positive to negative. So by PV first derivative test, it's a maximum. Alright, that's it. D, find all values of x on an open interval for which the graph of g has a point of inflection. Okay, so point of inflection, it's when the first derivative, which we have the graph of, hits maximums, right? Hits maximums. or minimums. So we have a min here and max there and max there. All right, so it's at x equals -4, -2, and 0. There are points of inflection because g prime of x, which is equal to f of x, has a relative max or min. Okay, that's it. All right, continuing. All right, let f be the function. So that's it. That's the end of that question. Now I'm going on to a different question. Let f be the function defined by this accumulator function. On which of the following intervals is the graph of y equals f of x concave down? Well, so concave down, when we talk about concavity, we need the second derivative. So we're going to use the second fundamental theorem of calculus to get the first derivative. When we take the first derivative, all we do is just copy that, right? 2x cubed minus 15x squared plus 36x. But we need the second derivative, so let's find the second derivative. Second derivative is 6x squared minus 30x plus 36. Set that equal to 0 and divide by 6. That'll be x squared minus 5x plus 6 equals 0. So it's x minus 3, x minus 2 equals 0. If I made a sign chart of this, we have 2 and 3. This is a parabola concave up, so it's plus, negative, positive. Alright, so we want concave down, so it's only on 2 to 3. So it's only D. And that's it. That's the answer, and that's the end of the accumulator function notes.